Here we got a setup of an RC circuit connected to a battery. So this is our circuit right here. We have a 7.8 volt battery, which is right over here, and it's connected to a 100 ohm resistor and then a 22,000 microfarad capacitor. So it's a fairly large capacitor. You can see it's the size of like a coffee cup. So if we compute the time constant, which is just the R times the C, so we get 2.2 seconds. So that's a fairly long time constant. We chose that because then you could actually visualize what's going on. So we have two multimeters set up here. So the one on the left is connected directly across the battery terminals. So right at these 2 points right here, positive and the negative. And then the one on the right is connected across the capacitor. So positive terminal over here, negative terminal is connected to a common ground. And so you could see, our initial conditions are that our capacitor voltage is 0. So in order to ensure that, I actually connected the resistor not to the positive terminal, but right to ground. So it's as if there was a wire going through this source right here. It's connected to ground, and that puts that capacitor in a 0 volt initial condition. So that's sort of like what a step function would have before time t equals 0. So we know with a step function, if we have a graph of time versus voltage, when time equals 0, it's going to step up to whatever the voltage is and stay at that voltage forever. So we could do the experiment now. So we're, initial conditions, we're at 0 volts. And then when I disconnect the capacitor from the lead, or the resistor from the negative terminal, it's still sitting at 0 volts. Now as I put it on the positive terminal, if you watch the multimeter on the right, you're going to see the voltage is going to start increasing. And it's increasing, with the time constant of 2.2 seconds. 5 time constants, or 11 seconds later, we are there. So our voltage is 7.6, our battery voltage is 7.8, so we're asymptoting to that final voltage, which is going to be approximately 7.8. Like we know in reality it never actually gets there, but for practical purpose it does with the precision of our instruments. So an interesting thing will happen. So what do you think is going to happen if I disconnect the resistor from the battery? And I'm doing that, and the voltage is dropping a little bit. That's because the capacitor is leaking a little bit. But it's not going back to 0 right away. And it's not going back to 0 because when we disconnected that wire, we literally put an open circuit in here. So the 100 ohm resistor isn't connected back to the source. So there's no current flowing through anything. The voltage across the resistor is going to be 0. So the voltage across the capacitor is going to be equal to the voltage on both resistor terminals. So if I wanted to discharge this capacitor, I need to actually connect this resistor to ground, which I'll do now. And if you notice, the meter here is starting to go down. Voltage across the capacitor is exponentially decaying back to 0 with a time constant of 2.2 seconds. You could say that after 5 time constants, you're basically all the way there. So 5 time constants times 2.2 seconds equals 11 seconds. Therefore, after 11 seconds, we should be pretty close to 0. And you can see there we're basically asymptoting back to 0 volts. So similarly though, if I disconnect the resistor, it's going to sit there and float, and there's a little bit of memory effect in the capacitor, so it's not going to stay exactly where it is. So it's important to realize that a lot of people might have desire to put a switch in here and say, okay, well, when I close that switch, I'm going to start charging the capacitor, and when I open it, it's going to discharge. But it's not going to discharge. If we break that loop by opening up that switch, a theoretically perfect capacitor will maintain that voltage forever across its terminals until this gets connected, say, back to ground if we want to disconnect it. And my action of moving this resistor between the positive and the negative terminal is really the action of these two switches opening and closing alternatively.